Well, today I'm with my friend Jon Brewton, founder and CEO of Data Squared. And Data Square has created the only patented and commercialized hallucination-resistant and explainable AI platform in the world. So, Jon, it's great to have you today.
Thank you, sir. I appreciate the time.
So let's get into why this is such a game changer when you talk about hallucination resistant and what the patent, what is it that the patent actually is on?
Yeah, so the patent is kind of fourfold in four major components. There's actually 21 different patent claims within structure, but I'd say the broader part of what we do sort of lends into four very distinct buckets. Is one, how we structure data within the context that we do. um, Ultimately how we pair that data with localized embeddings models or anything that we run in parallel. And what that would traditionally be referred to from the market is we have, at least as far as I know, the first sort of commercialized patent for graph RAG that's been done,
Okay.
and then we have a hybrid RAG patent as well, and we also have sort of the outcome by using these two sort of systematic approaches to retrieval. We can structure information in a way that sort of grounds the way language models think or see the world. And so, a lot of what you see from language models today, at least in terms of the performance of those models and the returns of those models, is essentially seeded through inferred context. When you ask a question, the words that you use matter within the context of how the model itself perceives that, and then what information it retrieves on that basis. It's essentially a statistical prediction engine based on that context. What we figured out from a patent perspective is if we structure information in a certain way, we can control the way that these models see that information and the
Mm.
context within. So we can kind of lock the way they think. It's a little bit of like how we hack the system. But what that allows us to do is pass information in a highly contextualized manner within a context. And when we do that, the model sort of sees that for what it is. And so in practical application, what we're doing is saying, here's all the things that you need to know about this data. Here's how it's connected. Here's the who's, the what's, the whens, the where's, the whys if we have them. Use that to figure out, what you need to retrieve from your training corpus to inform how you answer these questions, but lock all of the answers that you provide to the data that you've been provided and the context within. And so that allows us to create hallucination resistant outcomes because we control what we pass that system, what is used by that system, what is returned by that system. The fact basis of it is actually verified on return. And then we can actually get into sort of the chain of cognition and understand how it's weighting certain things and ultimately how those models are coming to the conclusions that they are and start to tune those up within the context of the subject matter or the application space we're trying to operate in. And so that's really what our patent is. It's sort of
Mm.
how we structure data from a graph perspective, how we run that in parallel with sort of localized or general embeddings models, how we use both of those structures in combination with one another to lock the way that language models see the world and the context within the data that we're passing to them, and then ultimately how we can validate, audit, and see transparently the chain of cognition associated to any query. So that's really our patents in a
Okay.
nutshell. What makes it slightly different is we run really universally harmonized multimodal data models. So we use semantic graphs. We're able to really structure them in a way that allows us to use structured, semi-structured, unstructured, time series, photographic evidence, you name it, we can put it into a harmonized unified data model, and we can contextualize that model on the basis of the problem that we're trying to solve, which just ups the recall efficacy of these systems very
Mhm.
significantly. And because we can see that chain of cognition, we can start to tune it up and we go from native performance of around 86% to 99% very, very quickly.
Got it. So what's the problem with the black box that you mentioned in some of your podcasts or the website?
Yeah.
Is the black box versus what you
Well,
guys provide?
well, in theory, there's sort of nothing wrong with black boxes unless you're trying to apply them to, say, high reliability regulated industry. which is where our background comes in. So
Right.
the entire company is a veteran-owned, veteran-run company. We have a lot of experience in the defense and intelligence space, and that coupled with the fact that we're engineers by background, not data engineers, not computer engineers. I was a petroleum engineer working for Chevron for
Hmm.
many years, and so like we carry this sort of we need to prove our work with anything we're sort of doing systematically or at scale. And those were the imperatives with which we sort of built this because we don't see a path, a logical path forward to scalable AI implementation in high reliability industry. Think defense, intelligence,
Hmm.
engineering, finance, healthcare without real transparency into how those systems are working, what information they're retrieving, how they're weighting the things that they're doing. We have to have that sort of inspection layer to be able to have faith that these things are working correctly. If we're going to apply them to things that, in worst case scenario, could get people killed,
Hmm.
and we want to make sure that we're building really high integrity solutions on that basis for those industries.
Got it. I read in one place that using the old method might be to throw 20 bodies at the problem. The new method would be to maybe have
Yeah.
three analysts plus your review platform, and you can still get way more done. So explain that a little bit.
Yeah. Yeah, I'll give a good concrete example in a commercial setting. One of the oil companies that we work with bought eight different companies over the course of about 18 months. And they were really struggling with integrating the data from these different companies because there's a lot of contractor overlap. You'll have some instance of Schlumberger for company A, B, C, D,
Mm.
E. And Schlumberger will have a different contracted base for each one of those companies. And now we need to harmonize all of those things. And now we actually need to pass that into the finance department and then reconcile across each one of these chart of accounts and these P&Ls from these different entities that are now being rolled up into one. That in and of itself is really, really difficult because now we're talking about multiple systems of information. This company we were working for was employing 28 contracted financial analysts. And these 28 analysts, all they did was look at invoicing discrepancies and account reconciliation. So we built a tool for them really quickly where we used all the wells information, all the system information. We took all their contracts holistically. We took all their commercial agreements. We took all of their chart of accounts. We harmonized all those chart of accounts. We took all the vendor records. We harmonized those vendor records. We squared away the differences from each one of the existing contracts and then allocated them to asset areas where they were active within the context of where those operations were taking place for the previous entity. And then we created a tool where we could upload a PDF invoice and it would check all of these things
Mm.
simultaneously against what we could extract from this. And then it would reconcile how to route that invoice, what AFEs it needed to be allocated to, what percentages needed to be allocated to it, and whether or not it was valid against the price book and the contractual terms that were relative to that point in time. That allowed them to get rid of 25 contract analysts.
So with that, you mentioned the concept of time to value. So that's
Yes.
that's a great case study right there.
It is. And I think a couple of things that we do really different, and I've talked about it on a couple of different podcasts, but we created a tool called Review Studio. We don't talk about it much because the patent stuff is still in works right now, but I'll talk about it super high level. We created a tool where we can take disparate files of different types. I'll give a great example. We took the entire drilling completions and production history from the Gulf of Mexico. These are all public records from the Bureau of Ocean Energy Management. We ingested those documents. We created an enterprise ready graph, and we were able to query across that graph and all the information from the different corporate entities in less than 5 minutes. Now, that is probably about a 10,000% increase in speed in terms of the development of the graph itself. But that brings like actual time to value forward by about 95% for
Mm.
traditional network problems that have bifurcated information sources across sort of a wide array of time and systems. And so it's sort of a tool that we have built to make things really, really easy, really, really fast. And it gives us a lot of competitive advantage.
So what about the ideal target prospect for you? I know you mentioned intelligence, three-letter agencies, energy, engineering, but what are some industries that could also use your platform?
Look, I think anywhere where you can think of problems that you can work that can create value. And I know it's a bit arbitrary, but I'll give you a great example in context. So, supply chain is a great one. If we're looking at secure supply chain or contested logistics, one, how do I get my materials correctly in the right order of time so that I can service the clients and the delivery needs that I have? The other is how do I get the things that I've already built and I need to deploy to the right people at the right time? Those are network problems. So in general, if we can
Mm.
define the inputs and the outputs within the structure of the network, the data dependencies that we need, we can start to build a graphical representation of what that network is and how it functions. So supply
Mhm.
chain is a perfect area that's a sort of network-based problem where you can take a lot of disparate information and start to make better decisions that create a lot of value. Financial services is another area where you could start to look at real value creation. How do I make better investment decisions? What does history tell me about the performance of this asset, and what does that mean to its peers, and what does that mean for how I value these assets? Things of that nature are pretty doable within structure. And then the rest of it is sort of engineering problems. How do I engineer a better outcome? Well, history is a good determining factor for that, but how do I take like today's circumstance, today's information, overlay it with history, and then make a better decision in real time
Mm.
about how I can re-engineer something if I need to. It's kind of those critical applications that we're looking at, things that have a high cost of failure. If we get something wrong, loss of life, loss of asset, damage to
Mm.
assets, damage to reputation. That's really where we want to play, and that's where our stuff is really fit for purpose and scaled application. But healthcare is a great place. Preventative maintenance is a great place. We've worked on a number of different things with a number of different companies.
I think also you mentioned trust and adoption of AI and how your platform is a game changer in helping companies with their AI journey because now it really changes the game as far as trust and adoption of these systems.
Yeah, and this whole prove your work imperative. I'm an engineer by background. I've worked in sort of intelligence and defense. We're not going
Mhm.
to make decisions, especially things that are meaningful, without really kind of going through the motions to understand how we got to those conclusions. We're talking about 100 million, $1 billion investment decisions. We want to make sure we can show our work and prove our work. And so that's kind of where we started as an organization is how do we build a system that can do that? And because we can bring transparency to the market, transparency to the solution space, regardless of the LLM or the data or the architecture we're operating in, because we can do that, we create real trust and transparency in the system. But not only that, when our system runs, our general Q&A, just in the sort of typical way you would see Chat GPT, every answer that's produced shows you what data it's actually accessing, the data that's being consumed by the system, what data is being returned from the system, the underlying file structure. Everything in every line is sourced and cited to the data record level in the overall
Wow.
data environment. So we're not talking about, hey, it's in a spreadsheet somewhere. No, it's in workbook X,
Mm.
tab, whatever, cell column reference. Here it is. And here's how it's connected to the rest of the information we use. And so it's like a full 360-degree view of
Mhm.
your information environment, how we're consuming it, how we're using information. And that's really what we sort of hang our hat on.
What's new on the horizon?
Well, we're really working towards moving into the European market. We've got a lot of discussions going on in the UK and Europe, also trying to figure out a way to break back into the Australian, New Zealand market and really start to grow our global presence. But I think a lot of it is, at least in North American context, us really leaning into different vertical markets and applications, specifically
Mhm.
financial services. And I think healthcare is sort of the next horizon for us.
Yeah, sounds super exciting. How would you like people to get in touch with you or reach out or engage?
Yeah, it's three ways. You can find me on LinkedIn. We're not too sophisticated. We don't have too many handles or any of these
Okay.
other places. You can find me on LinkedIn at Jon Brewton,
Okay.
JonBrewton. You can find the company at Data2US. That's Data Squared on LinkedIn. And then our website is data2.ai. And luckily, it's going through a refresh right now. So hopefully, those updates will be live here pretty soon.
Cool. Well, I'm looking forward to seeing the growth and excitement around your company and your solution and just staying in touch and just watching it grow.
I really appreciate that. Thank you for the
Yeah.
time today.